Next, we're going to be finding the standard deviation of a random variable probability distribution. The variance is before you square root it. Standard deviation is after you square root it, put it back in the original units. You'll notice there we're not dividing by n because the division already happens when we find the probabilities. We're dividing by the n to find these, to calculate these. So here we have a probability distribution. First we're going to calculate the mean, the variance, then the standard deviation. So a computer monitor is composed of a very large number of point of lights called pixels. It's not uncommon for a few of these pixels to be defective. So our random variable x is going to represent the number of defective pixels on a randomly chosen monitor. The probability distribution of the defective pixels is as follows. First, we're going to find the mean, then the standard deviation. So remember, our mean is the sum of the random variable x times each of its probabilities. So that's going to be this next column here. I need to add these up to get my mean. So 0 number of pixels at 0.2, that's going to be times, so 0, 1 times 0.5, 2 times 0.4, 3 times 0.1. Then I'm going to add all these up. So the average number of defective pixels is 1.2. Then, to get my standard deviation, I have a lot of steps to do. I need to first calculate the mean, which we did. Then we need each number of pixels distance from the mean. Then I need to square that to get rid of any negatives. Then multiply that by each probability, and then add the sum of all those, and then square root. So all of that is broken down. Our first step is x minus the mean. Here we go. Alright, so 0 number of defective pixels minus the average number of pixels is negative 1.2. It's 1.2 defective pixels below average. That's what that's saying. 1 minus 1.2 is negative 0.2 below average. 2 minus 1.2 is above the mean. 3 minus 1.2, 1.8. So next, the formula says, hey, let's square these values to get rid of any negatives. I just dropped the negative sign. Be careful when you square something. You really should put it in parentheses. Negative times a negative is a positive, or you can just drop the negative signs at this point. Then, if you can see my calculator, it says take this value and multiply it by each probability. So this column times here. These are the numbers I'm multiplying. 0.2 times 1.44. 0.5 times 0.04. 0.2 times 0.64. 0.1 times 3.24. Then the formula says let's add that column up. Sorry. So the variance is before you square root it, is 0.76. After you square root it, that is the standard deviation of the random variable x. So the standard deviation rounded to 2 decimal places is about point. So if the average number of defective pixels is 1.2, the standard deviation from that is 0.87.